Alright, so we're going to look at more angles that are about a circle. These angles are outside the circle, and they all have the same formula, which is kind of nice. So it says it up here, secants and or tangents intersect on the exterior of a circle, so the angle's outside the circle, then the measure of the angle formed is equal to half the difference, so it's a subtraction of the intercepted arcs. So for instance, angle A here is 1/2 of arc CE minus BD. Make sure you do the big one minus the small one because we don't want negative angles. That's two secants. If we have a secant and a tangent, still the same thing. It's 1/2 the difference of arc BD, so this outside, minus arc BC, the inside one here. And angle A, when we have two tangents, there's only two arcs. So it's still the same thing. Arc BDC, so all the way around here, minus arc BC. So it's again half the difference of the arcs that they cut off, or that they make. So let's try some of these. So angle KML, or LM, and I'm just going to write out my formula, is equal to 1/2 of arc JN minus KM, because those are the two arcs that are cut off by them. So angle KLM is equal to 1/2 of 140 minus 66. 140 minus 66 is 74. Oops. Half of 74 is 37 degrees. So the measure of KLM is 37 degrees. And that's how we do these. And that was a secant-secant angle. This next one is a secant-tangent angle. A little bit different, but the same idea. So angle, excuse me, ABC, this one is equal to 1/2 the big arc, AD, which there should be another letter here because it's definitely, well, I guess maybe it's not over 180 degrees, minus arc AC. So angle ABC is equal to 1/2 of AD. I don't know what AD is. But I do know that there's only three arcs. There's arc AC, CD, and DA in the circle. And the circle is 360. So I can figure out what that arc is because they should all add up to 360. And it's actually 266 when we do the math there. So it's 1/2 of 266 minus 62. 266 minus 62, 204. Half of 204 is 102 degrees. So the measure of angle ABC is 102 degrees. Alright, now we have a tangent-tangent angle. So same thing, we still want to look at the difference. Here is one arc, and the other arc is here. They make up the whole circle. So we know that angle PQR is 1/2 of PSR, arc PSR, minus arc PR. So that's 1/2 of 313 minus, and again, we don't know what that is, but we know 360 minus 313 is going to be what's left in the circle. That's 47 degrees. So 1/2 of 313 minus 47, 266, and cut that in half, 133 degrees. for the measurement of angle PQR. So those are the basics. We'll go through some of these problems a little bit quicker now, but I want us to write out the statement. Angle BCD is equal to 1/2 of arc AE minus arc BD. Again, we don't have BD, but we know 94 and 67, and we know that this is a diameter, so it's going to make up a semicircle. So it's 180 minus 94 minus 67 will give us arc BD. So 180 minus 84 minus 67, this arc in here is 29 degrees. So it's 1/2 of 67 minus 29, which is 1/2 of 38. So we got 19 degrees for the measure of angle BCD. Alright, now we have the angle, and we got to find an arc. And this is why I want us to write out the formulas. So angle SU, or TUV, let's use angle TUV is equal to 1/2 arc SW minus arc TV. Well, we don't know angle TUV, or we do know angle TUV, it's 40. We don't know SW, so we'll just leave that. We can mark it X, but I'm going to leave it as SW, and TV is 75. So what do we do here? Well, first, let's get rid of that 1/2 and multiply by 2. So we get 80 equals arc SW minus 75, and then add 75 to both sides. So the measure of arc SW equals 155 degrees. You're just working backwards. And that's what these last problems are. Just working backwards. Again, angle TSR is equal to 1/2 of arc QU minus arc TR. Again, the difference of those two arcs here and here. We know the angle is 35. We don't know QU, that's what we're trying to find, arc QU. And we know the arc TR is 46. So we multiply by 2, is 70 equals arc QU minus 46. Add 46 to both sides. And the measurement of arc QU is 116 degrees. Notice I'm putting the measurement of arc QU. Arc QU can't be a number. The measurement can be. So let's just finish off these last two problems. Same type of thing, but more practice is always good. So angle MLK is equal to 1/2 of arc KM minus the arc KM. We know the angle. We know the bigger arc this time, but we don't know the little arc. Again, we multiply by 2. We have to subtract 160. Just going to double check my calculations. So I get negative 48 equals negative Km. Well, we divide by negative 1, and the measure of arc Km is 48 degrees. Alright, last one. Again, we're looking for an arc, so angle FGH equals 1/2 of arc EH minus arc FH, the two arcs that they cut off. So we know the angle is 77. We know the big arc, 191, but we don't know arc FH. Multiply both sides by 2. Subtract 191. I get negative 37 equals negative arc FH divided by negative 1, and the measure of arc FH equals 37 degrees. So those are our angles outside of a triangle.